Control structures in R allow you to control the flow of an R program, and are very similar to the control structures that you might see in other types of programming languages. The basic constructs are things like if, else, for testing logical conditions, the for executing a loop a fixed number of times, while executes a loop while a condition is true, repeat is a construct that allows you to just to immediately execute an infinite loop. Break allows you to break out of any type of loop. And next skips an iteration of a loop, and return allows you to exit a function. So most of these control structures are not things that you use in interactive sessions, so not like while you're typing at the command line in R. These are the kinds of things that typically you would use when you're writing a R program or an R function, so a little bit more of a structured format. So the first structure is if. So this is the if combined with else allows you to test logical conditions and to let the R program do something, depending on whether or not that condition is true or false. So if the condition is true, then you do something. Else you do something else. That's a typical kind of construct. The else part is optional, so you could just have an if statement to do something if something is true. But you can have the else part if you want to do something alternatively. If you want to do more, if there's more than one possible type of condition you want to check, you can say if and then else if and then else. Else if, there can be any number of else if conditions in a construct like this, and the else one has to be at the end. So there are a couple of different ways that you can formulate the if-else construct in R. This is a little bit different from other languages, in case you haven't seen something like this. So the first is pretty standard. If the symbol x is greater than 3, then you set y equal to 10. If it's not greater than 3, then you set y equal to 0. So that's inside the if-else construct. There's an assignment of y to a specific type of value depending on what the value of x is. But however, in R you can do it a different way. You can say y is equal to the entire if-else contract. So if x is greater than 3, 10, or 0, depending on whether that condition is true or not. So this is a valid formulation also. Sometimes it's useful to read this type of writing because it allows you to realize that the entire if-else construct is all about assigning a value to y. So as I said before, the else clause is not really necessary. You can always test a condition and do something, and then do nothing if that condition happens to be false. So you can just test multiple conditions in a row if you want. So the next construct is a for loop. So this is probably the most common type of loop operator that you're going to use in R. The basic idea is that you have a loop index, which is typically called I, but if you have many loops, you might say J, K, L, etc. And the loop index is going to cover a sequence of numbers, typically integers. So for example, here I've got a for loop, and it's looping over the numbers 1 through 10. So I've created the sequence with the colon operator, 1 through 10. And this for loop is not doing anything particularly interesting. It's just printing out the number, so I'm printing out I at each iteration. After the loop is finished, it continues on to the next block of code. So there's different ways to use a for loop. And R is pretty flexible about how you can kind of index the different types of R objects. So here I've created a character vector with the letters A, B, C, D in it. And all of these for loops are equivalent. So for example, in the first one, I kind of done what you might commonly see in other languages like C that have for looping. Here I've got an index I that I sequence through 1 through 4. I create an integer sequence. And then I print out the ith element of x each time. So here, this loop just prints out A, B, C, D. Another thing I can do is use the seek along function. So seek underscore along. What it does is it takes a vector as an input, and it creates an integer sequence that's equal to the length of that vector. So this is a vector of length 4, so it's going to create an integer sequence of 1 through 4. It's exactly the same as the previous statement where I've got the sequence 1, 4. However, here I generate the sequence based on the length of the variable x. So now my index variable I is going through this sequence. It's printing out the ith element of x, and exactly the same behavior occurs. I print out A, B, C, and D. The third example here I've got a different index variable. I'm calling it letter, and the index variable is actually going to be taking values from the vector itself. So there's no reason why the index variable has to be an integer. It can take elements from any arbitrary vector. So now the for loop is going through this vector of letters A, B, C, D, and it's just going to print out the letter itself. So now I'm printing out the index variable, which happens to be equal to the letters in the vector. And so these three for loops are exactly the same so far. The last version here is the same as the first one, except that I haven't included the curly braces. And so for a single expression, if the for loop only has a single expression in its body, you can omit the curly braces and put everything on one line, which may be useful sometimes because it's a little bit more compact. But it's not my particular style. For for loops, I generally like to put the curly braces in, regardless of how many elements are in the body. For loops can be nested, so you can have a for loop inside of a for loop. So the common thing, for example, is with a matrix that has 2 dimensions, and then you might want to loop over the rows and then loop over the columns. So here, the outer loop, the I with the I index is looping over the rows, and I'm using a function that's called seek_len. So the idea is that it takes seek_len takes an integer, which in this case happens to be the number of rows in X, and then it creates an integer sequence out of that. So so this particular matrix has 2 rows, and so it's going to create the sequence 1 to 2. For example, similarly, the nested loop with the J index is using the number of columns to create a sequence. So this matrix has 3 columns, and so the seek_len function is going to create an integer sequence 1 through 3. So this doubly nested for loop is basically printing out all the elements of the matrix. So one thing to be careful with nested for loops is that it's going beyond 2 to 3 levels. While it's theoretically okay in R, it makes reading the code a little bit difficult to do. And so if you're reading code that has 3 or 4 nested for loops, it gets difficult to understand what's going on. Sometimes that's the logical thing to do, but many a times there's ways to get around that, for example, by using functions. So the while loop is the other major looping construct in R, and the basic idea is that the while takes a logical expression and will execute the loop based on the value of that logical expression. So for example, I've got a very simple loop here. It initializes a count variable equal to 0, and then while that count is less than 10, it prints out the count and then increments the count by 1. So as soon as the value of count gets to 10, the loop stops, and then it'll go on to the next body of code. So the while loop is useful because it makes things easy to read sometimes. It's very obvious here that this loop is supposed to stop working or stop executing when the value of the count variable is 10 or more. So it makes it a little bit more readable. However, you have to be a little bit careful with while loops because technically speaking, they are infinite loops and you have to make sure that the condition that stops the loop will actually occur. Otherwise, your program will never finish. And so in this case, it's fairly obvious that the loop will eventually stop executing. But in much more complex pieces of code, it can be hard sometimes to figure out whether the while loop will finish. And so often it's safer to use something like a for loop that has a hard limit on the number of times it can execute. So that's not necessarily saying that you should never use a while loop, but you just have to be careful when you do use them. So you can test multiple conditions in a while loop or in any type of construct like an if statement, for example, by using the logical operators. So here I've got a variable z, which I initialized to the value 5, and the condition for the while loop is basically while z is greater than or equal to 3 and it's less than or equal to 10. So while it's between the values of 3 and 10, then what I'm going to do is going to print the value of z. I'm going to flip a coin, a fair coin. And if the coin is a 1, I'm going to add 1 to my value, and then if it's less than 1, if the coin is equal to 0, or any other value for that matter, I'm going to subtract 1 from z. So I'm generating a little random walk here, and the value of z is going to go up or down depending on my little coin flip here. So here you can see it's a little bit harder to tell when the while loop will finish, because the body of the while loop involves random number generation. So here the z value is going to zigzag up and down until it eventually hits 10 or eventually it hits 3. or something less than 3. And so this may be kind of nice, but you have to be careful that it doesn't go off for too long. So one thing to note on a more technical level is that the conditions when R tests the condition in a kind of a multi-expression condition. Here I've got z greater than or equal to 3 and z less than or equal to 10. The conditions are always evaluated from left to right. So it checks to see if the leftmost condition is true, and then it goes to the next condition. So first it'll check to see if z is greater than or equal to 3. If that's true, then if that happens to be true, it'll go to the next expression. It'll check to see if z is less than or equal to 10. So if those are both true, it goes on to the next into the body of the loop. Repeat is a construct that basically initiates an infinite loop. This is not what I would characterize as a commonly used control structure in R, but it does have its use occasionally. So the only way to exit a repeat loop is to call break. So obviously you're going to have to call break at some point, unless you feel like running your program, forever. So here is a pretty simple example. Here I'm initializing a value of x0 to be 1, and I'm setting what I think of as a tolerance to be 10 to the minus 8th. And then I'm going to repeat the following structure. Basically, I'm going to imagine that there's some function that computes an estimate for x, and then I'm going to call that x1. And basically, if the new value of x, that is x1, if the absolute value of the difference between x1 and x0 is less than some tolerance, so in this case 10 to the minus 8th, then I'm going to stop the loop and then move on to the next bit of code. If the difference is greater than my tolerance, then I set x0 to be equal to the new value, and then I run the loop again. I calculate a new estimate, and I check to see if the difference is small. So this is a common type of formulation in many types of optimization algorithms. For example, if you're trying to find the solution to some set of equations, or you're trying to maximize a function, often you'll iterate over and over again, and you'll stop when the estimates that you're calculating are getting closer and closer together, because that's usually a sign that you're kind of converging to whatever the minimum or maximum of the objective function is. So in theory, this is a perfectly reasonable construction. You want to keep recycling through the algorithm until the two values are close. So there's one problem, which is that, first of all, it requires an algorithm that is guaranteed to converge, and not necessarily every algorithm has that property. Second of all, also it does depend a little bit on the tolerance, so the loop will run longer if the tolerance is smaller, generally speaking. And because it's hard to predict how long this loop will run, it can be a little bit dangerous because it's unpredictable. It could theoretically run forever, and you have no way to guarantee that the program will stop at some point. So this construct, although it's theoretically kind of the right thing to do, it's usually not a good idea. It's probably better off to use a for loop that has a hard limit on the number of iterations that it's allowed to run. That way, if you have a problem with your algorithm, it will eventually reach the hard limit and stop, and you'll know that the reason it stopped is because it didn't converge, and then maybe you can try to fix something about the algorithm. With the repeat type of approach, if your algorithm is not converging, you won't have any warning. It'll just be running a really long time. The last control structure element I want to talk about is next, and then there's also return. Next is basically used in any type of looping construct when you want to skip an iteration. So here I've got a basic for loop, which is going to run for 100 iterations. But the idea is that I want to skip the first 20 iterations and then only kind of execute some code for iterations 21 through 100. So here I've got a very simple if condition. So if I is less than or equal to 20, I'm just going to skip. So I use the next expression, and it'll skip everything else in the for loop and go and iterate again. So once I gets beyond 20, then of course the expression I less than or equal to 20 will be false, and so it won't execute the next. It'll go into whatever the body of the code for the for loop is. So next is a way to skip an iteration in a loop, and of course break is a way to exit the loop entirely. The return function is another function that can use to be exit a loop, and it's primarily used to exit a function. So it'll exit the entire function and return a value that you pass it. So we'll talk more about return when we talk about functions, but it's something that can interrupt the flow of a program too. So that's control structures for now. So the basic summary is that control structures like if, while, and for that can allow you to control the flow of an R program. Generally speaking, while there are constructs that kind of allow you to execute infinite loops, you generally want to be on the lookout for these kinds of things and to avoid them if possible, even if they are kind of theoretically correct, because they can lead to kind of some unpredictable behavior in programs. And the other key thing I haven't mentioned yet is that the control structures that I mentioned here are primarily useful for writing programs. I think I mentioned that in the beginning. But for command line and interactive work, there are other types of looping type functions that we can use. They generally have the word apply in them, and they can be a lot more useful for command line interactive work when you're exploring data and things like that, not writing programs, although they can be very useful in writing programs too. So I'll talk about the apply functions in a separate set of videos.